ಟೈಮ್ ಕಮ್ಮಿ ಆಯಿತು.
This is the life cycle of the pavement, and we know that this is the critical phase. The production phase is the most critical phase. And coming to the management assurance, that should be there in all levels. Here, not only here. Whatever we do here is quality control. Whatever we do here in this phase, it's called quality control. These are the layers. If we look at the requirements, from the bottom we start with weak materials, and as we go up and up, we go for stronger materials. For the reason, here the stresses are more below the wheel loads. Hence, it is always necessary to have the stronger materials here. As we go down, the stress distribution happens, stress level decreases, so we go for inferior material compared to its top layer. And now, coming to the soil layers, whether it is embankment or the subgrade layer, the most critical or salient quality control aspects are for all, both for embankment layer as well as the subgrade. Number one, thickness of the layer, soil layer. The maximum allowable thickness is 200 mm. Loose thickness. Why? How? So it is to be determined. Thumb rule we say it's about 30%. But to be precise, that's what the construction method says. We need to construct mock-up to begin with for that project, for that machinery. This is the additional thickness, loose thickness to be adopted to get the required compactor thickness of 200. So it is not by thumb rule, it is by the mock-up. And that's very, very important. One is thickness should not be more, that is one, for soil layers. The second thing is uniform thickness. Here I got 200, and then next I got 150, next I got 190, next I got 220. That is also not good, to be precise. So I do not get uniform density all along. My objective of constructing this foundation layer subgrade is I want a uniform layer having equal strength all along. So now when my density varies, why density varies? I have put non-uniform thickness, so I get non-uniform density. So that should be looked into. One is thickness not to be more than 200. Second is non-uniform thickness. And the other important probably is neglected water content. We know that the density we get at a particular water content, highest density we get at a particular water content, OMC. Theoretically speaking, so we should spread the loose thickness, get the sprinkler, sprinkle the water, bring the rakers, mix it, then grade it to required cross and longitudinal profile, then compact. But practically speaking, we don't do. How we do? We spread the layer. At the most, we sprinkle the water tonight to evening. Tomorrow morning, we come and compact. So that means it's a fact that at only a particular water content for that material we can have an optimal density, highest density. So that means when we are not doing this, if you put more water content or less water content, we are not optimizing that material, soil material. So that's one. And the vice versa, the other part of this is there is no water for drinking. Then how can I use that 9% OMC? It runs into several thousand liters. This is a huge quantity. summer season. I cannot take water from the local tank or anything, and I cannot drill. Even if I drill, I may not get water. So what is that? We are talking about OMC and there is no water. So this is, we need to balance. Suppose for any of such instances, it's always desirable to compact the layer at OMC so that that particular material we get optimal benefit, optimal density. Maybe if that is not possible, then probably we need to run more passes, or reduce the thickness. So, and what does it mean? I am using more fuel, more equipment resource, and so on. So there is a compromise.
More passes we get.
Sometimes we may not. ನಂದು 8 ಟನ್ 10 ಟನ್ ಏನೋ ರೋಲರ್ ಇರುತ್ತೆ, ಅದು ಎಷ್ಟು ಅಚೀವ್ ಆಗಬೇಕು ಅಷ್ಟು ಅಚೀವ್ ಆಗ್ಬಿಟ್ಟಿರುತ್ತೆ. ಇನ್ನು ಅದಕ್ಕಿಂತ ನಮ್ಮ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ರೈಸ್ ಮಾಡಬೇಕು, ಏನೋ ವೆಯ್ಟ್ ಆಫ್ ದಿ ರೋಲರ್. ಅದೇ ರೋಲರ್ ನೆಕ್ಸ್ಟ್ ಸಾರಿ ಹೊಡೆದ್ರು ಅದಷ್ಟು ಅದೆಷ್ಟು ಮಾಡ್ಬೇಕು ಮಾಡ್ಬಿಟ್ಟಿರುತ್ತೆ.
ಸರ್ ಈಗ ಎಂಬಾಕ್ಮೆಂಟ್ಗೆ ಆಪ್ಟಿಮಮ್ ಆಕ್ಷನ್ ಹಾಕಿರ್ತಾರೆ ಬೆಳಗ್ಗೆ ರೋಲ್ ಮಾಡೋಕ್ಕೆ ಲೈಟ್ ಹೆವಿ ರೈನ್ಸ್ ಆಗ್ತದೆ
ಅವಾಗ
ಆಲ್ವೇಸ್ ಈ ಪರ್ಟಿಕ್ಯುಲರ್ ಕೇಸ್ ಅಲ್ಲಿ ನಮ್ಗೆ ಇಲ್ಲ, ಇವತ್ತೆಲ್ಲ ಪಾಪ ನಾನು ವಾಟರ್ ಕಂಟೆಂಟ್ ಬೇಕು ಅಂತ ಚಿಮುರ್ಸಿ ಹೋಗಿರ್ತೀನಿ ನೀರು, ಇದಕ್ಕಿಂತ ರಾತ್ರಿ ಮಳೆ ಬಂದ್ಬಿಟ್ಟಿರುತ್ತೆ, ಏನು ಮಾಡೋಕ್ಕಾಗಲ್ಲ. ವಿ ಹ್ಯಾವ್ ಟು ಸ್ಟಾಪ್.
ಯೂಶಲ್ ನಾವೇನ್ ಮಾಡ್ತೀವಿ 1 or 2 days ಏನು ಮಾಡೋದು ಬಿಟ್ಬಿಟ್ಟು ಅವಾಗ ಸ್ವಲ್ಪ ಎವಾಪರೇಟ್ ಆಗುತ್ತೆ.
ದಟ್ಸ್ ದಿ ಓನ್ಲಿ ಮ್ಯಾಟರ್. ಬೇರೆ ಇನ್ನೇನು ಮಾಡೋಕ್ಕಾಗಲ್ಲ. ನೀರು ಹೋಗ್ಬೇಕು. ಏನೋ 1% ಆ ಕಡೆ ಈ ಕಡೆ ಅಂತಂದ್ರೆ ಏನಾರು ಮಾಡ್ಬೋದು. ನೀರಿದ್ರೆ ಏನು ಮಾಡೋಕ್ಕಾಗಲ್ಲ, ನೀರು ಹೋಗ್ಬೇಕು. ಲ್ಯಾಬಲ್ ಆದ್ರೆ ಬೇರೆ ಏನಾದ್ರು ಮಾಡ್ಬೋದು, ಫೀಲ್ಡ್ ಅಲ್ಲಿ ಸೊ ಆ ಥರ ಸಿಚುವೇಶನ್ ಖಂಡಿತ ನಿಲ್ಲಿಸಲೇಬೇಕು. ಅಂಡ್ ಅದರ್ವೈಸ್ ವಿ ಡೋಂಟ್ ಗೆಟ್ ದಿ ವೆದರ್. ವಾಟರ್ ಕಂಟೆಂಟ್ ಜಾಸ್ತಿ ಆದಂಗೆ ನಮ್ಮ ಡೆನ್ಸಿಟಿ ಕೆಳಗಡೆ ಹಿಡಿತಾ ಇರುತ್ತೆ, ಹಿಂಗೆ ಹೋಗಿ ಹಿಂಗೆ ಹಿಡಿಯುತ್ತೆ. ಅಂದ್ರೆ ನಾವು ಈ ಸೈಡಲ್ಲಿ ಎಲ್ಲೋ ಇರ್ತೀವಿ, ಎಷ್ಟು ಪಾಸ್ ಮಾಡಿದ್ರು ಆ ಡೆನ್ಸಿಟಿ ಲೆವೆಲ್. And then the second aspect need to be considered in soil layers is we need to target highest density that is possible by whatever the means. ನಾವು ಲೇಯರ್ ಥಿಕ್ನೆಸ್ ಕಮ್ಮಿ ಮಾಡ್ತೀವೋ ಅಥವಾ ನಮ್ಮಲ್ಲಿ ಚೆನ್ನಾಗಿರೋ ಎಕ್ವಿಪ್ಮೆಂಟ್ ಇಲ್ಲ, ಏನು ಮಾಡೋದು ಅಂದರೆ ಲೇಯರ್ ಥಿಕ್ನೆಸ್ ಆದರೂ ಕಮ್ಮಿ ಮಾಡೋದು ಇಲ್ವಾ, ಅಷ್ಟು ಡೆನ್ಸಿಟಿ ನಮಗೆ ಟಾರ್ಗೆಟ್ ಹೈಯೆಸ್ಟ್ ಡೆನ್ಸಿಟಿ ನಮಗಿರೋ ರಿಸೋರ್ಸಲ್ಲಿ ವಾಟ್ ಈಸ್ ದ ಬೆಸ್ಟ್ ಡೆನ್ಸಿಟಿ ಐ ಕ್ಯಾನ್ ಅಚೀವ್, ದಟ್ ಶುಡ್ ಬಿ ದಿ ಟಾರ್ಗೆಟ್. ಇಟ್ಸ್ ನಾಟ್ 97% or 95% embankment or 97% or some rate. So I have a material here and these are my resources, equipment, plant or whatever. With that, what is best that can be achieved? That should be the target. It's not 100% target ಅಂದ್ರೆ first yes, ಒಂದು ಪಾಸ್ ಎಕ್ಸ್ಟ್ರಾ ಹಾಕಿ ನಾನು 100% ಮಾಡ್ತೀನಿ ಅಂದ್ರೆ ಖಂಡಿತ that should be the target. After all, this is the foundation. And all the stress comes on this and again it gets distributed from there. So this should be strong and the entire stability for the pavement structure is given by this foundation. So that should be the highest. And soil is more stable, we get more strength, etc. only when it is at its highest density. Strength and density are highly correlated. So it is not 95% or 97%. We should target the highest density possible.
The minimum is to be
minimum, that is specifications, 95% for embankment, 97% for subgrade.
In case, suppose, hypothetical question, if it crosses 100, then whatever lab density we have given is wrong.
Yeah, ಖಂಡಿತ.
100 crosses. ನಾವು ಲ್ಯಾಬ್ ಅಲ್ಲಿ
ಮಾಡಿಸ್ಬೋದು 100 ಹಾಕ್ಬೋದು. ಹೇಗಂದ್ರೆ ಲೇಯರ್ ಥಿಕ್ನೆಸ್ ಕಮ್ಮಿ ಮಾಡಿ ಅದೇ ಹೈ ಆಲ್ಟಿಟ್ಯೂಡ್ ಅಲ್ಲಿ
ಬಂದ್ರು ಓಕೆ
to be appreciated. And it is possible. But that's what we always should not restrict to 95 or 97. Target should be the highest. And below resource alli ನಾನು highest density ಮಾಡಿದ್ದೀನಿ ಅಂದ್ರೆ ಏನು, apart from stability strength, what does it mean? I get more CBR. Same soil, 97% density. I have met my specifications here. 97% for subgrade. Same soil layer, now mine is 99, let's say. I made something, I made more passes, so 99 here. Both cases I have met the specifications. 2% more here, and here I am meeting. So what does it mean for me? Here CBR I may get 9, here I may get 11. Just because increase of 2% CBR. So what does it, 2% increase in the density, field density. So what does it mean for me? Cost implications or the pavement composition. All the above layers, top layers, again you look based on the CBR. The top layer thickness reduces. Not only the strength and stability. The cost of construction, cost of the layers or thickness of layers also gets reduced. Just by increasing the density by 1 or 2%. And that is possible. That is possible. That is possible. Except for high plastic clay silicone or bit almost all ನಮ್ಮ loamy soil ಏನಿದೆ. For that we can achieve really more than 97, 98. 97 is very very easy. ಈ ಬೆಂಗಳೂರು ಮಣ್ಣು ಹಾಕ್ಬಿಟ್ಟು 6 ಪಾಸ್ ಹೊಡೆದ್ರೆ ಟೆಸ್ಟ್ ಮಾಡೋದೇ ಬೇಕಿಲ್ಲ. ಬಂದಿರುತ್ತೆ. Only requirement is 200 mm ಇರಬೇಕು. Loose thickness ಒಂದು 250, 260 ಆ ರೇಂಜಲ್ಲಿ. And 260 is also not constant. 260 na 250 na ಅದು ಕನ್ಫ್ಯೂಸಿಂಗ್. ನಾನು 30% ಲೂಸ್ ತಗೊಂಡು 260 ಯಾವಾಗಲೂ ಹಾಕೋದು. No, we don't know. Many times if you compact the 260 loose thickness, we may not get 200, we may get 210. And then always whenever we are compacting the soil layers, to get this high density we need to target high amplitude compactor, low thickness, vice versa for the bituminous layers. And another important thing is many times this happens. Subgrade ಅವಾಗಲೂ ಕಾಂಪ್ಯಾಕ್ಟ್ ಮಾಡಿರ್ತೀವಿ, ಎಂಬಾಂಕ್ಮೆಂಟ್ ಅವಾಗಲೂ ಕಾಂಪ್ಯಾಕ್ಟ್ ಮಾಡಿರ್ತೀವಿ, ಆಮೇಲೆ ಎಷ್ಟೋ ಒಂದು 3-4 ತಿಂಗಳು ಆದ್ಮೇಲೆ ಅವಾಗಲೂ ಇನ್ನೊಂದು ಲೇಯರ್ ಶುರು ಮಾಡಕ್ಕೆ ಇದು ಚೆನ್ನಾಗಿ ಸೆಟ್ ಆಗಿರುತ್ತೆ, ಗಟ್ಟಿ ಇರುತ್ತೆ, ಫುಲ್ ಡ್ರೈ ಇರುತ್ತೆ. ಮೇಲ್ಗಡೆ ಫೀಲ್ಡ್ ಮಾಯಿಶ್ಚರ್ ಕಂಟೆಂಟ್ ಆ ಕನ್ಸ್ಟ್ರಕ್ಟೆಡ್ ಲೇಯರ್ ಅಲ್ಲಿ 1-2-3% ಇದ್ದೇ ಇರುತ್ತೆ. ಅದ್ರ ಮೇಲೆ ಹೋಗಿ ನಾನು ನೆಕ್ಸ್ಟ್ ಲೇಯರ್ ಮಾಡುವಾಗ ಮತ್ತೆ ನಾನು ಏನಾದರೂ ವೈಬ್ರೇಟರ್ ಓಡಿಸಿದ್ರೆ ಇಟ್ಸ್ ನಾಟ್ ಗುಡ್. ಹೈ ಆಂಪ್ಲಿಟ್ಯೂಡ್ ಒಂದ್ಸಾರಿ ನೀರು ಚಿಮಿಸಿ ಸ್ಟ್ಯಾಟಿಕ್ ಪಾಸ್ ಮಾಡಬೇಕು. ನೀರು ಚಿಮಿಸಿ ಸ್ಟ್ಯಾಟಿಕ್ ಪಾಸ್ ಮಾಡಬಹುದು ಅಥವಾ ಮೈಲ್ಡ್ ವೈಬ್ರೇಷನ್ ಅಲ್ಲಿ ಏನಾದರೂ ಓಡಿಸ್ಬೋದು. ಇಲ್ಲ ಅಂದ್ರೆ ಅದ್ರ ಮೇಲೆ ಮಾಮೂಲಿ ರೆಗ್ಯುಲರ್ ಆಗಿ ನಾನು ವೈಬ್ರೇಷನ್ ಹಾಕಿದ್ರೆ ಮತ್ತೆ ಅಲ್ಲಿ ಕ್ರಾಕ್ಸ್ ಮಾಡ್ತಾರೆ. ಅಕಸ್ಮಾತ್ ಎಲ್ಲೋ ಲೋಕಲೈಸ್ ಫೇಲ್ಯೂರ್ ಸಿಕ್ತು ಅಂದ್ರೆ ದಟ್ ಶುಡ್ ಬಿ ಪ್ಯಾಚ್. ರೀಕನ್ಸ್ಟ್ರಕ್ಷನ್ ಏನು ರೆಗ್ಯುಲರ್ ನಾವು ಕನ್ಸ್ಟ್ರಕ್ಷನ್ ಏನು ಮಾಡ್ತಿದ್ವು ಆ ಇದರಲ್ಲಿ. ಸೊ ದಟ್ ಈಸ್ another important. This is the gradation, and this is the allowable limits, tolerance given for different. This is the deviation allowed for the gradation. Lower the gradation, lower is the size of the material, the tolerance is less, and for bigger size tolerance is little more. This is for wearing course, this is for base and binder course, wet mix and DBM, and this is for BC, SC, BC. So gradation not to deviate from this, not to deviate from this. When it comes to the temperature, it is plus or minus 10 tolerance. And this is not a good practice. Stacking wet mix macadam heaps. That's not good practice. Extreme cases where, ideally speaking, wet mix macadam to be paved. That is the right practice. Maybe for some of the reason it cannot be paved. That case, extreme case, it's a discretion of engineering charge. You can take a call. I have a grader model. But that should not be the practice. Wet mix always to be paved.
Specification grading.
It should be paved answer irutte.
Grading no allowed.
Grader is GSB ಗೆ grader ಇದೆ. Wet mix ಗೆ paver use ಮಾಡೋದು. Wet mix ಗೂ extreme engineer in charge can tell that, but that is not the practice.
ಡೈರೆಕ್ಟ್ ಆಗಿ ಪಗ್ ಮಿಲ್ಲಿಂಗ್ ಬರ್ತಿರಾಗೆ
ಪೇವರ್ ಹಾಕಿ ಮಾಮೂಲಿ ನಾವು ಬಿಟುಮಿನಸ್ ಲೇಯರ್ ಹೆಂಗ್ ಮಾಡ್ತೀವೋ ಹಂಗೆ ಮಾಡ್ಕೊಳ್ತೀವಿ. ದ ಐಡಿಯಾ ಈಸ್ ನಮ್ಗೆ ವೆಟ್ ಮಿಕ್ಸ್ ಆಗಿರೋ ಪದನೇ ಆ ಮಿಕ್ಸ್ ಅಲ್ಲಿ ವಾಟರ್ ಕಂಟೆಂಟ್ ಇರಬೇಕು ಅಂತ ಅಟ್ ಅ ಟೈಮ್ ಆಫ್ ಪೇವಿಂಗ್ ಅಂಡ್ ಕಾಂಪ್ಯಾಕ್ಟಿಂಗ್. ಅದಿಲ್ಲ ಅಂದ್ರೆ ಡ್ರೈ ಮಿಕ್ಸ್ ಆಗ್ಬಿಡುತ್ತೆ. ಕ್ರಷರ್ ಅಂಡ್ ಮೆಕಾಡಮ್ ತರ ಬಿಹೇವ್ ಆಗುತ್ತೆ. ದಟ್ ಇಸ್ ಆಲ್ಸೋ ಗುಡ್. ಈಚ್ ಒನ್ ಹ್ಯಾಸ್ ಗಾಟ್ ಒನ್ ಅಡ್ವಾಂಟೇಜ್ ಅಂಡ್ ಡಿಸ್ಅಡ್ವಾಂಟೇಜ್. ವೆಟ್ ಮಿಕ್ಸ್ ಅಂದ್ಮೇಲೆ ನಾವು ಡ್ಯೂರಿಂಗ್ ಕನ್ಸ್ಟ್ರಕ್ಷನ್ ಪ್ರೊಡಕ್ಷನ್ ಪ್ರೋಸೆಸ್ ಅಲ್ಲಿ ಅದರಲ್ಲಿ ಮಾಯಿಶ್ಚರ್ ಕಂಟೆಂಟ್ ಇರಬೇಕು. ಸೊ ದಟ್ ಐ ಗೆಟ್ ಬೆಟರ್ ಡೆನ್ಸಿಟಿ, ಸೊ ದಟ್ I get what is that, less segregation. I can maintain my gradation properly when there is a moisture content because of less segregation. Water yavagirallo that becomes dry macadam, and in that case it is also okay. Nothing, there is no big difference except segregation is more. Segregation, and that is not desirable. Aggregate layer gradation is important.
Water control model.
No, but joke ವೆಟ್ ಮಿಕ್ಸ್ ಗೆ ಅದನ್ನೇ ಒಂದ್ಸಾರಿ ಫ್ರೆಂಡ್ಸ್ ಜೊತೆ ಜೋಕ್ ಮಾಡ್ತಾ ಇರ್ತೀನಿ. ಸರ್ ವೆಟ್ ಮಿಕ್ಸ್ ಎಲ್ಲಿ ಮಾಡಿದ್ವಿ ಸರ್? ಏನ್ ಸರ್ ಅಲ್ಲಿ ನೋಡ್ ಬಂದ್ವಿ ಮತ್ತೆ ವೆಟ್ ಮಿಕ್ಸ್ ಮಾಡ್ಲಿಲ್ಲ. ಇಲ್ಲ ನಾನಂತೂ ನೋಡ್ಲಿಲ್ಲ. ಏನ್ ಸರ್ ಹಿಂಗ? ಸೊ ಸಾಹೇಬ್ ಹೇಳಿದಕ್ಕೆ ವೆಟ್ ಮಿಕ್ಸ್ ಮಾಡಲ್ಲ ಹಂಗಂತ ಹೇಳ್ಬಿಟ್ಟು ಅದರಿಂದ ಏನ್ ಸಿಕ್ಕಾಪಟ್ಟೆ ಡಿಫರೆನ್ಸ್ ಏನ್ ಖಂಡಿತ ಏನು ಆಗಲ್ಲ. ಬಟ್ ಅದಕ್ಕೆ ನಾವು ವೆಟ್ ಮಿಕ್ಸ್ ಅಂತ ಕರೆಯೋದು ಬೇಡ. ವೆಟ್ ಮಿಕ್ಸ್ ಅಂತ ಕರೆಯೋದು ಬೇಡ. ಡ್ರೈ ಮೆಕಾಡಮ್ ಅಂತ ನಾವು ಕ್ರಷರ್ ಅಂಡ್ ಮೆಕಾಡಮ್ ಅಂತ ಏನಾದ್ರು ಕರ್ಕೋಬಹುದು. ಸೊ ಅಲ್ಲಿ ನಾವು ಈ ಅಡ್ವಾಂಟೇಜ್ ತಗೊಳಕ್ಕಾಗಲ್ಲ. ಏನು ಸೆಗ್ರಿಗೇಷನ್ ಸ್ವಲ್ಪ ಜಾಸ್ತಿ ಇರುತ್ತೆ. ಅದನ್ನ ಒಪ್ಕೊಂಡಂಗೆ ನಾವು ಇಲ್ಲಪ್ಪ ನಮ್ಗೆ ವಿ ಹ್ಯಾವ್ ಅವರ್ ಓನ್ ಲಿಮಿಟೇಷನ್ಸ್ ಫಾರ್ ವಾಟ್ ಎವರ್ ದ ರೀಸನ್. ಸೊ ಐ ಆಮ್ ನಾಟ್ ಯೂಸಿಂಗ್ ವೆಟ್ ಮಿಕ್ಸ್ ಮೆಕಾಡಮ್. ನಾನು ಅಲ್ಲಿ ಹೀಟ್ ಮಾಡಿ ಇವತ್ತು ಬೆಳಿಗ್ಗೆ ಹೀಟ್ ಮಾಡಿ ಮಧ್ಯಾಹ್ನ ನಾನು ಗ್ರೇಡ್ ಮಾಡ್ತೀನಿ. I'm not telling pressure and macadam is inferior. I mean inferior ಮಾಡಬಾರ್ದು ಅಂತ ಹಂಗಿದ್ರೆ ಹೆಸರು ಕರಿಬಾರ್ದು. And the payment can be made for pressure. ವೆಟ್ ಮಿಕ್ಸ್ ಮೆಕಾಡಮ್ ಅಂದ್ರೆ ಆ ಮಿಕ್ಸ್ ಅಲ್ಲಿಂದ ಪಗ್ ಮಿಲ್ಲಿಂದ ಬರಬೇಕು, ಪೇವರ್ಗೆ ಅನ್ಲೋಡ್ ಆಗಬೇಕು, ಪೇ ಮಾಡಿ ಹಿಂದ್ಗಡೆ ರೋಲರ್. So these are the salient aspects, QC aspects for aggregate layers. So we always the strength of aggregate layers comes by interlocking. That is the reason in the MORT book they say it should be crushed to crushed surface so that we get better locking. And gradation also helps in interlocking. And lateral confinement is another big requirement here. And not to expose aggregate layer without bituminous layer for longer duration. This is another thing. That is one of the biggest drawback of this aggregate layer, whether it is non-plastic GSB or macadam, is this. I mean, it's a practical problem because we don't have service roads or diversion roads. So it gets disturbed. Once a wet mix macadam ಮೇಲೆ ಎಲ್ಲ ಕ್ಲೀನ್ ಆಗೇ ಮಾಡಿರ್ತೀನಿ, ಬಟ್ ಟ್ರಾಫಿಕ್ ಹೋಯ್ತು ಅಂದ್ರೆ back to square one. So that's somehow ಇರೋ ಲಿಮಿಟೇಷನ್ ಅಲ್ಲಿ what best we can do, how best early we can go for a bituminous layer covering or whatever is that should be the model. And again here also I have seen wet mix ಹಾಕಿರ್ತೀವಿ, ಎಲ್ಲ ಕೂತಿರುತ್ತೆ, ಮತ್ತೆ ನಾವು ಪ್ರೈಮ್ ಕಾಂಟ್ಯಾಕ್ಟ್ ಹೋಗೋ ಅಥವಾ ನೆಕ್ಸ್ಟ್ ಲೇಯರ್ ಹಾಕೋವಾಗ ಸೇಮ್ ನೀರು ಚಿಮಿಸ್ಬಿಟ್ಟು ರೋಲ್ ಹೊಡಿತೀವಿ, 3 ವೈಬ್ರೇಷನ್ ಹೊಡಿಸ್ತೀವಿ. ಡೌಟ್ ಇದ್ರೆ ಒಂಥರ ರೀಕನ್ಸ್ಟ್ರಕ್ಷನ್ ತರ ಮಾಡಬೇಕು. ನನ್ ಡೌಟ್ ಇದೆ ಇಲ್ಲಿ ಏನೋ ಸರಿ ಇಲ್ಲ ಅಂತಂದ್ರೆ ಇಟ್ ಶುಡ್ ಬಿ ಎ ರೀಕನ್ಸ್ಟ್ರಕ್ಷನ್. ದಿಸ್ ಒನ್. ಸೆಕೆಂಡ್ ಈಸ್ ಐ ಹ್ಯಾವ್ ಸೀನ್ ಯಾರಾದ್ರೂ ಇನ್ಸ್ಪೆಕ್ಷನ್ ಬರ್ತಾರೆ ಅನ್ನೋವಾಗ ಡಸ್ಟ್ ತಗೊಂಡು ಹಾಕ್ತಾರೆ, ಚೆನ್ನಾಗಿ ಕಾಣಿಸ್ಲಿ, ಫುಲ್ ಡಸ್ಟ್ 6 mm down. There is another no layer. Even if you look at wet mix macadam or any well graded mix, that's not desirable. More than 5% is not desirable. Any layer corridors to 5% ಮೇಲೆ ಇರಬಾರ್ದು. ನಾವು ಏನಕ್ಕೆ ಅಂದ್ರೆ ಯಾವಾಗಲೂ ವೆಟ್ ಇರ್ತೀವಿ ವೆಟ್ ಮಿಕ್ಸ್ ಮೆಕಾಡಮ್ ಅಂದ್ರೆ ಗಾಡಿಗಳು ಹೋದ್ರೆ ಸ್ವಲ್ಪ ಟೈಟ್ ಆಗಿ ಹಿಡ್ಕೊಳ್ಳಿ, ಸ್ವಲ್ಪ ಕಿತ್ತು ಬರೋದು ಕಮ್ಮಿ ಆಗಲಿ, ದಟ್ ಈಸ್ ಅಕ್ಸೆಪ್ಟೆಡ್. ಡೈವರ್ಷನ್ ರೋಡ್ ಇರಲ್ಲ. ಬಟ್ ನೆಕ್ಸ್ಟ್ ನಾನು ಲೇಯರ್ ಹಾಕುವಾಗ ಡಸ್ಟ್ ಹಾಕ್ತೀನಲ್ಲ ಚೆನ್ನಾಗಿ ಕಾಣಿಸ್ತೀನಿ, ದಟ್ ಈಸ್ ನಾಟ್ ಗುಡ್ ಪ್ರಾಕ್ಟೀಸ್, ನಾಟ್ ಗುಡ್ ಪ್ರಾಕ್ಟೀಸ್, ನಾಟ್ ಗುಡ್ ಪ್ರಾಕ್ಟೀಸ್. ಸೊ ದಟ್ ಮೀನ್ಸ್ ವಿ ಆರ್ ಆಲ್ಟರಿಂಗ್ ದಿ ಗ್ರೇಡೇಷನ್, ದಟ್ ಈಸ್ ನಾಟ್ ಡಿಸೈರಬಲ್, that is not desired. So and to be precise, theoretically speaking, wet mix nan bere next layer wet mix mele hogok munche, what is that we expect the exposed surface of the coarse aggregate before I go for prime coating interface treatment. What is expected is wet mix macadam layer alli aggregate surface expose agirbe. So most of the times interface dust jaasti, so that bonding getting. So these are the two things. And these are the different types of bituminous layers. Bituminous layers. Structural, functional, BC, DBM, BM, PMC, so many things. SMA, so many layers are there. End of the day, in any bituminous mix, these are the ingredients. 95% is jelly, aggregate, and about 5% is the binder. 5% is the binder. That means, what is this binder? Peculiar material. At some temperature it is solid, at some temperature it is liquid. Even this solid can be liquid if it is stored for continuously for long duration. So, that, I mean, end of the day, you give any name for the bituminous mix, nothing we are changing. Either we are changing the gradation of the aggregates and a partial, a small variation in the binder content. DBM go BC go yen anta difference illa binder content arda %. So athwa BM go BC gadre 1-2% irutade. So a small variation in the binder content and a variation in the binder content is the only thing we do, and we give different names for different purpose. Nothing else. And tolerance, gradation is very, very important in the granular layer, or in the bituminous layers also gradation is very, very important. And these separators, these racks in the HMP or in the pug mill helps us. ಯಾಕಂದ್ರೆ ನಾವು ಲಾರಿ ಬಂದು ಹಿಂಗೆ ಅನ್ಲೋಡ್ ಮಾಡ್ತಾ ಇರುತ್ತೆ, ನಾವು ಒಂದ್ಸರಿ ಇದನ್ನ ಸೆಟ್ ಮಾಡಿರ್ತೀವಿ ಓಪನಿಂಗ್ಸ್. ಲಾರಿ ಅವ್ನು ಹಿಂಗೆ ಬಂದು ಸ್ಟ್ರೈಟ್ ಆಗಿ ಹಾಕಲ್ಲ, ಒಂದೊಂದ್ಸರಿ ಹಿಂಗ್ ರಿವರ್ಸ್ ಹೊಡೆದಾಕ್ತಾನೆ ಅಥವಾ ಹಿಂಗ್ ರಿವರ್ಸ್ ಹೊಡೆದಾಕಿರ್ತಾನೆ. ಅಂದ್ರೆ ಈ ಮೆಟೀರಿಯಲ್ ಜಾಸ್ತಿ ಆಗ್ಬೋದು, ಈ ಮೆಟೀರಿಯಲ್ ಕಮ್ಮಿ ಆಗ್ಬೋದು, ಈ ವೇರಿಯೇಷನ್ ಜಾಸ್ತಿ ಇರುತ್ತೆ. ಸೊ ಅದಕ್ಕೆ ಮೇ ಬಿ ಟು ಮಿಟಿಗೇಟ್ ಲಿಟಲ್, ಮೇ ಬಿ we can have racks here also, so that when dumper unloads, this material do not get mixed up with another hopper material in another hopper. So ಇಲ್ಲಿ horizontal ways, ಈ directional ಸ್ವಲ್ಪ ಜಾಸ್ತಿ ಆಗ್ತದೆ, so that when he unloads, this material will not go there. That's one advantage. And the question is, suppose if this is the least temperature we can think of during the construction for the rolling. Suppose the question is, what should I do with the mix? The temperature is less than 90 degree. So it is as good as aggregate, not to be used. And in case of modified binders, still it should be rolled at higher temperature. Suppose if this temperature, this is the lowest, if temperature is lower than this, again it is as good as aggregate. This is somehow we need to practice. Since I think second or third revision I am seeing, they say in the orange book. But we know temperature is very crucial. But still, I don't know. We need to practice. Covering the mix with tarpaul is the right thing. Construction, when it comes to the paving, everything should be synchronized. In the sense, the the speed of the paver should be adjusted to ensure even and uniform flow of material across the street. That's one. Next, the rate of delivery of material to the paver also to be synchronized. I am paving here. My HMP plant is, let's say, 20 kilometers away or 30 kilometers away. That output of my HMP and my transport dumpers capacity and my speed of the roller all to be synchronized. So theoretically speaking, at no point of time when I start the paving, I should not stop for any of the exceptional reasons. So that is called paving. It's not that easy to synchronize the production of HMP, transportation and the paving, but effort should be in that direction. Ideally, paving is that's called paving. But it's not that, but at least the target should to synchronize this. But most of the time, whether it is NHA projects or other projects, this is not seen. That means we are not doing the paving, we are not constructing. So end result is what? We are creating weak planes. No wonder. The moment I stop my paver, that means I am creating a weak area there. So every here and there I am stopping and I am creating weak planes. That means the life of the same stretch, same length, the life of the mix, performance of the mix, we do not get uniformly. That fails wherever my paver stops for some time for loading or weight, loading to happen. That area fails first. We get traveling, etc. So this is more important. During paving also, the screed, the load on the screed should be uniform, preferably to the middle depth of the auger. Paver auger in rotary. Adar mid depth ge nam mix irtave. Nam paver mix iradre. Auger mid level irbeku. Any mixer for that matter, pug mill agirbodu, namma any mixing unit irbodu. ಆ ಪ್ಯಾಡ್ಗಳು ಮಿಕ್ಸ್ಗಳು ಏನೇ ಇರುತ್ತೋ ಅದ್ರ ಮಧ್ಯದ ಲೆವೆಲ್ಗೆ ನಾವು ಲೋಡ್ ಮಾಡ್ತೀವಿ. ಓವರ್ ಲೋಡ್ ಆಯ್ತು ಅಂದ್ರೆ we do not get uniform mixing in the mixing unit. Underload ಆಯ್ತು ಅಂದ್ರೆ segregation ಆಗುತ್ತೆ. So here also in the paver, we should the operator should pull the load such that it is off to the auger height. Suppose if that is not the case, then we do not get the profile. It will not be uniform. And the end objective of the paving is to have a uniform profile. So that we do not get. This is what happens. If it is overloaded, we get a hump there. If it is underloaded, auger is underloaded in the paver, we get a depression there. Other thing is this what? No rest during paving. It should be continuous. Same time there should not be too many experts. Maybe one or two is sufficient. So rolling, construction wise always, joints always should be vertical. Rolling sequence, first we should roll transverse joint. Then comes longitudinal joint. Then comes lower to higher. Sequence. Transverse, longitudinal and then lower. So these are most important things to be followed during uniform speed of the roller. We should not allow compactor to stand on the hot layer, no jerky start, no sudden braking. Change of lane to be made only on already compacted surface. Steel, we should always remember that we use asphalt compactors which has got steel wheels on front and back. So that means it absorbs heat of the bituminous mix. It does compaction, at the same time it absorbs the heat which is not desirable. So always we should balance that. And these are some of the other things we should remember. Overheating because my stretch is too far, and then I don't want the mixed temperatures to come down than the requirement so that I get blamed. So what I do is I heat my mix more than the requirement, then that is dangerous. If I overheat the mix than the specified, so I lose my sticking property. Hence the life of the bitumen comes down. And early raveling or all things happen. Raveling. And overheating is that. Heating for long duration is also dangerous. In the sense, mix is heated for long duration. It's in the drum only for long time. It should be unloaded immediately once the mixing is over. Or I covered and it differs at high temperatures, especially dense mix, my CGPS or so, MSS. I have stopped my paving operation. It is standing there, my dumper with MSS or CGPS standing there from morning till 4 o'clock. Generally, the temperature do not comes down except in the top layer. You see MSS and all. So that means what? I kept my bitumen mix for a longer duration covered with tarpaulin at very high temperature. Then also my sticking property comes down. And another important, the exposing DBM layer. Generally, DBM layer is also a dense mix layer. Nothing to worry. But only it's okay for short duration, and we can allow the traffic without covering with a BC layer. But exposing DBM layer, thinking that it's a dense layer, it can take up the load. No, it will not, and it fails prematurely. Life comes down drastically unless it is covered with a wearing course very soon. Paving for shorter stretches should be avoided, and no case we should put high vibration on the bituminous layer. It's dangerous. After all, 40 or 50 mm layer for 10 paver itself, if we want. In fact, majority of the paver now the pavers that is coming out from this time, they themselves will give 70-80% compaction, and hardly we need another 10-15% from the roller. It means, I don't know, going further, maybe hardly we may need any roller pass. 1 or 2 is sufficient. Our entire compaction is done by paver. Also has got vibrator. If that is done properly, majority of the compaction is done by paver. So, and when compactor is used, roller is used, we should ensure that it's a thick layer. If we do it with high amplitude, then the entire layer will go off.
At the time of construction, especially this wearing course, how to ascertain required degree of compaction has been ascertained?
No, sir. Now
because for other layers we can do so many, maybe after laying 1 or 2 days or maybe weeks. But this has to be ascertained instantly.
So the best method is if you can insist the contractors, you should use rollers only with having compaction gauges. That's possible. It's hardly cost anything. Almost the compactor meters with rollers are given on demand. All companies they give. ಒಂದು ಸ್ವಲ್ಪ 50,000 ಜಾಸ್ತಿ ಆಗ್ತದೆ. 20 ಲಕ್ಷ ತಗೊಂಡು
15 ಲಕ್ಷ ಆಗುತ್ತೆ ಓಲ್ವಾದರು
ಏನು 15 ಲಕ್ಷ ರೋಲರ್ ಸಿಗುತ್ತೆ ಮೀಟರ್ಗ ಕಾಂಪ್ಯಾಕ್ಟ್ ಇಲ್ಲ ಅದು ದಟ್ ಈಸ್ one thing you can do quickly, and that's the easiest and best way. There itself, during rolling itself, operator himself, you can see the reading and stop. That's the ideal way, and that should come, in fact. That gives an indication. Of course, that is not the end. We need to do a quality check and confirm ourselves by doing regular checks. You would have done the mock-up, sir, initial, for that material, for that number of passes using that machine. I would have known the density achieved. Unless I change my quarry, unless I change my mix ingredients, unless I change my compactor, I know this so many passes, this is the density I get. So we should go by that. And end of the day, of course, anyhow we will take course and check the density.
But later on we can't rectify it now.
That's civil engineering. That's what the first thing is: construct markup, fix up the specs. Anything changes in the team, if people, if the material is changed, if the machinery is changed, place is changed, new markup. Because uncertainties are many. And so suppose as sir said, now I am happy now because I thought 98% or whatever the required quality achieved. but I go checking after day after tomorrow. So if I do not get the requirement, what should I do? That shouldn't happen. No solution. No. And this should not happen. It should be straight. It looks so simple. But that creates a weak link. It's a very simple thing. ಹಳೆ ಕಾಲದಲ್ಲಿ ನಾನು ನೋಡಿದಂಗೆ ನಾನು ಚಿಕ್ಕವನಿದ್ದಾಗ ಕ್ಲೀನಾಗಿ ನಮ್ಮ ತಾರ ಹಾಕುವಾಗ ಕ್ಲೀನಾಗಿ ಇದು ಹಾಕಿ ಮಾಡ್ತಿದ್ರು. ಅದು ಯಾಕೋ ಏನೋ ಇವಾಗ ಮಾಡಲ್ಲ. ಬಟ್ ದಟ್ಸ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ದಟ್ ಎಂಟೈರ್ ನಾವು ಫೇಲ್ ಆಗೋದೇ ನೋಡಿ ಫಸ್ಟ್ ಅಲ್ಲಿ ಆ ಕ್ರಾಕ್ಸ್ ಅಲ್ಲಿ ಜಾಯಿಂಟ್ಗಳೆಲ್ಲ ಫಸ್ಟ್ ಫೇಲ್ ಆಗುತ್ತೆ. Right. Preferably vertical. Yeah.
ಸರ್ ಫೈಬರ್ ಕೋಟು ಹಾಕುವಾಗ